Lesson 80 is on operations with scientific notation. You were introduced to scientific notation back in Lesson 74, so if you're still not real good with scientific notation, you might want to go back and review that lesson before doing this one. And I think the best way to understand how to do some operations, and the operation we'll be doing is multiplication, doing that with scientific notation, I think you can just do some practice problems to learn how to do that. So look at practice problem A. And what I want you to do is simplify that relationship. Now that looks kind of confusing and complex, but the first thing you should do on a problem like this is get all of the terms in standard scientific notation form. So let's just start doing that. Start with the top left value, 0.05 times 10 to the third. That means we need to move the decimal place to the right 2, and when we move it to the right, remember we add negative values to the exponent of 10. And so we would say 5 times 10, we moved it to the right 2, so that would be negative 2 plus 3 is just 5 times 10 to the 1, or 5 times 10. And then the next one, 60,000, that would just be 6 times 10 to the 4. 4 times 10 to the 5, we don't need to do anything to that. And then 300,000, that will be 3 times 10 to the 5th. Okay, now simplify the numerators. And actually first we could cancel some of those factors in front of the 10 to the 4th or to the 10 power. And the 6 over 4, that would simplify to 3 over 2. And then the 3 over 3, that would simplify to 1 over 1. Now let's go ahead and multiply numerators and denominators together. And so we'll have 5 times 10 to the 1. Let's just go ahead and put that 1 on there. And when you multiply with scientific notation, you just have to think of everything as multiplication. And order doesn't matter in multiplication. So really what we have here, we can think of it as 5 times 10 to the 1 times 1 times 10 to the 4th. That's really how we can think about that. Order doesn't matter in multiplication, so we can do the 5 and the 1 together, and that would be 5 times the 10 to the 1 and the 10 to the 4. That would end up being 10 to the 5th. And so let's just rewrite that like standard scientific notation format is 5 times 10 to the 5th. So when you're multiplying scientific notation, just think of everything as being multiplied together, which it is. Sometimes people tend to forget that because you're separating the 4 and then the power of 10 part, or the 3 and the power of 10 part, or whatever is in front of the power of 10. But what are you separating it with? A multiplication sign. So it's all multiplication that's going on here. So now let's look at the denominators, and we have 2 times 10 to the 5th times 3 times 10 to the 5th. So that would just equal 2 times 10 to the 10th. And so now what we can do is simplify this expression. 5 divided by 2 is just going to be 2.5. And we separate that part in front of the scientific notation, or in front of the 10 power. We separate that separately from the powers of 10. Now look at the powers of 10. 10 to the 5th over 10 to the 10th. That would be 10 to the 5 minus 10, or 10 to the minus 5th. So there's our simplification of that problem. 2.5 times 10 to the minus 5. So one trick in thinking about scientific notation is that we keep that factor in front of the power of 10. We think of that as separate from the power of 10, but at the same time remembering that the power of 10 is just a factor. It's multiplied by that value in front of it. If that confuses you, how we can just divide the 10 to the 5th and the 10 to the 10 and think of that separate from the 5 and the 2, well, just remember that they're factors, and think of something really simple like 2 times 6 over 2 times 3. Now, in a problem like that, we could combine that together and have 12 over 6 equals 2, or we could keep them separate like that and cancel the 2's out, and then the 6 over 3 would simplify to 2 over 1. So we can keep them separate because they're factors. That's what we can do with factors, and then we can simplify it to 2 over 1 or just 2. So in the same way, powers of 10 that are factors of another value, we can keep those separate as well and do separate division problems with each. Let's do one more. Practice problem B. We want to simplify this relationship, so the first thing we want to do is get everything in standard scientific notation form, and then it makes it easier to work with. Now, of course, you could type all of these in your calculator and figure out the answer, but that's not what they want you to do here. The goal here is to get practice working with scientific notation. So the top left one, 0.03 times 10 to the minus 5, we move the decimal place to the right 2, and that would give us 3 times 10. We moved it to the right 2, so we add negative 2 to the exponent of negative 5, and that would give us negative 7. Next, we have 12 times 10 to the 8, so we need to move the decimal place to the 1, so we'll have 1.2 times 10 to the 9. We have to add 1 to the exponent since we moved the decimal place to the left 1. And then the denominator, 0.0009, we move the decimal place 1, 2, 3, 4, 5 to the right, and so that would give us 9 times 10 to the negative 5. And then the last number, 1 million, we would move the decimal place to the left, 1, 2, 3, 4, 5, 6, so we'd have 1 times 10 to the positive 6 since we moved the decimal place to the left. And hopefully that makes sense to you. I mean, 10 to the 6th is equal to 1,000,000 times 1. That still gives you 1,000,000. Now let's look for things to simplify. 3 over 9, we could reduce that to a 1 over 3. And that's about it. So let's go ahead and simplify the numerator. 1 times 1.2 is 1.2. And then multiply the powers of 10. 10 to the minus 7 times 10 to the 9th. That would just be 10 to the positive 2. And then in the denominator, 3 times 1 is 3. And then multiply the powers of 10. And that would just give us times 10 to the 1 or just 10. I'll go ahead and put the 1 on there just so we can be thinking about it. Now let's go ahead and divide here. We have 1.2 divided by 3. And so that would be equal to 0.4. And then 10 to the 2 over 10 to the 1 is just going to be 10 to the 1. Now, we're not done. That's not standard scientific notation format. We need to move that decimal place to the right one. So we'll have 4 times 10 to the negative 1 plus 1. We move it to the right 1. We have to add a negative 1 to that exponent, so that's really 4 times 10 to the 0. And so we could just leave it like that in scientific notation. Although 10 to the 0 is just 1, right? So the answer is really just 4. But since we're using scientific notation here, we'll leave it 4 times 10 to the 0. So on operations like these, get everything in standard scientific notation format first. Reduce where you can. Remember that the powers of 10, those are just factors of the value in front of them. So things can be rearranged, but we want to try to keep the powers of 10 separate from the value in front of them. So we reduce, we multiply together, and then when we multiply the powers of 10, we add the exponents, and then we simplify the fraction that's left. Okay, well that's all for lesson 80.